I'll be talking about writing a provider skeleton, i.e. the minimum provider that libcrypto, that OpenSSL will be willing to talk with at all. So I'll go over a few things like fundamentals. What do they actually provide and the core types that they deal with? I'll show a first attempt, which really does absolutely nothing, and also show you how to make that provider built into the whatever library or application you happen to have. Handling some parameter requests, doing a query function, getting some config data, and I'll finish up with talking about the provider context, how to do error handling, and how to deal in what ways you can deal with a library context. So with no further ado, the fundamentals for providers, we modeled them to be as independent as humanly possible. So they have very little obligation vis-a-vis OpenSSL and libcrypto. There's no obligation to use any OpenSSL library functions. There's no obligations to stay with a specific C language level. There's no obligation even to be written in C, if that's possible. In case it's written in another language, you will have to get bindings for the two header files that are mentioned just below. The minimum dependency is on two header files. One is OpenSSL/core.h. The other one is OpenSSL/core-dispatch.h. And so the only real must is that provider must be written in a language that's ABI compatible with C, i.e. it has simple symbols, no symbol mangling or that kind of stuff, unless you want to make life really interesting for yourself. The same kind of function argument passing, so the C type of argument passing. So for example, it's a little hard to write them in Pascal because Pascal passes arguments to functions in the other order than C does. And you need to have a compatible structure specification so that it's in memory, the structures are laid out in a way that's compatible with the interfaces we provide or OpenSSL provides. What do providers provide? First of all, they provide implementation of diverse algorithms currently, and it's divided into operations. So they can separately provide digest functions, digest implementations, cipher implementations, signature implementations, which do verify also, MAC implementation, etc., etc., etc. And also a set of provider-wide functions, which are like base functions that are necessary for libcrypto to be able to access everything else that the provider provides. And to be able to interact, for libcrypto to be able to interact with a provider, there's a base set of identifiers mostly that need to be defined. And those are all defined by OpenSSL in the header file OpenSSL/core_dispatch.h. And those are all numeric identifiers. So we have we have function signatures coming with them in form of type defs. So those cover functions that are supported provider-wide, i.e. supported by the provider on a provider-wide level. Identifiers and function signatures for the OpenSSL upcall. So OpenSSL or libcrypto can pass a set of functions that it provides to the provider for the provider to call back to or doing upcalls. there are identifiers for the supported operations, so like digest, cipher, signature, etc., and identifiers and function signature for those operation functions that are necessary to implement digest, cipher, signatures, etc. That's a lot just in itself. There are some core types, we call them. These are structures that are publicly defined. So the struct in itself is in OpenSSL/core.h. Those are the very few structures that are used beyond normal C types like char pointers, ints, size t's, etc., to pass certain sorts of data between the provider and libcrypto. And it's basically the four that we see here. The first one is OSSL_algorithm, and this is a structure that combines a set of names, a property definition, and an implementation. And this is to implement one algorithm. This implementation, in turn, is an array of OSSL dispatch, which is the next type I'm talking about. So OSSL dispatch is a structure that basically combines a functional entity with a function pointer. So a whole array of them is used to describe the functions of a specific implementation. An OSSL item is a little like an OSSL dispatch, with the only difference that is that the pointer in it is a generic pointer. It's not a function pointer, so it's a data pointer. And it's basically there to be able to associate an identity with a pointer. And last and not least, we have OSSL param, which is a generic parameter structure, and we use it to pass diverse, more or less optional data to from provider implementations. I won't describe OSSL param in depth here. It's a bit more complicated than the others. There is a manual page that describes this type in depth. And for the rest of the talk, I will just assume that this has been read. So, next thing. Regarding C language, there's code in the upcoming slides. They're written in C. And because it's easier for certain things, I've chosen to write them in C99, which is not the C level, C language level that's part of OpenSSL code itself, but that's all right, because a provider, at least as a module, is completely separate. And the only thing that matters is the ABI between libcrypto and providers. If you plan on writing providers in an older C language level, there's some things that you will have to adjust. I'll refer forward to one slide that will be about error handling. That one is very specifically in C99, and making it in an older C language level is a bit harder. It's doable, but a bit harder. So here we have the first provider. Complete nonsense. It does nothing except writing hello world. And this is the absolutely minimum that is needed. You have to have a sort of init function. When you make your provider as a separate dynamically loadable module, it must be named OSSL provider init as shown on this slide. And for the arguments, it takes a handle, which is basically just an opaque pointer that can be used to refer back to whatever libcrypto holds as data for this specific provider instance. So anytime OSSL provider init is called, that creates a new instance of this provider. And in and out will be discussed later, just as well as provctx. Right now, I'm ignoring them except for out, which is the set of provider-wide functions that the provider passes back to libcrypto through this out variable. And as you can see, I have a completely nonsense such array of OSSL dispatch. It's the prob FNS, and that is what is getting passed back. This one will be populated with functions that libcrypto will need to use to interact with the provider as in further slides. So keep an eye out for that one. Here's a very simple, here's how you build it. I just compile, I've called it hello world.c. That's the file name I've used the whole way. And it's linked as a shared library where the OSSL provider is exported. And I'm showing a very short one how to load it. And what you can see is the result of OSSL provider actually got called because that's the printout that the function made. Continuing on, making it built-in is mostly a change that needs a separate application. So here I've made a very short application, and I've just now discovered that there's an error in it. It says nonsense between quotes. It should say hello world, so that it actually loads the hello world.so and nothing else. Or rather, it makes a hello world a provider. And if you see here, it uses the signature for OSSL provider init to make a reference to my provider init, my prov init, which is, if you look at the OSSL provider add built-in call, is what is passed. So this does the same thing as loading a dynamically loadable module, but does it kind of internally in a built-in way. And that's basically associating a name with an init function. And that's what gets loaded afterwards. And eventually unloaded as well. You should, if you load a provider explicitly, you should remember to unload it. And this is how it's built. I've made no changes to hello world.c, none at all. The only thing I do here is on the second compiling line, where I compile the provider itself, I do it just as an object file with the name OSSL provider init redefined as myprov init, which was the name that the application was using. If we go back and look at the just above main, that's the name. And the rest is just link it together, run the application. It says the same thing, this nonsense hello world. Now we get to some fun stuff. The provider can provide some parameters back to libcrypto, to OpenSSL, to do whatever it wants with. Like I said, I'm not going to go terribly in depth on what how OSSL param works, because that's basically a seminar of its own. So we have what we do is that we add two functions, one that is called gettable params. And what it does is that it returns an array of OSSL param to simply describe what it is it's able to handle, what parameters it's able to handle. The other one is get params, which is something that libcrypto calls to get parameters from the provider. And what libcrypto will do in this case is that it passes an OSSL param array with populated with diverse params it wants to respond to. And this function simply fills in whatever it finds that there is to fill in. So in this case, it goes looking for an OSSL param build info. And if it finds that parameter, it will fill it in with a commit identity. A note here is that in this case, I'm using OpenSSL functions to do the parameter handling, like we have OSSL param locate and we have OSSL param set UTF-8 pointer. But I said earlier that there's no absolute requirement on providers to use any OpenSSL functionality at all. So there is a way to do this entirely manually. And it looks approximately like this. It's exactly the same functions from a provider interface point of view. The macros that were used earlier that were about the parameter keys, the parameter names, are now exchanged to strings. You have quotes build info end quote, and there's a for loop to go around the parameters in get params, and very basic C functions are used to find out what is there, what do I need to fill in, how do I do it. And the final thing to do in the provider is to fill in the provider-wide functions. And this very little diff shows how that's done. We're connecting the identity OSSL from provider gettable params to the gettable params function, and the same with get params. There's one thing in here that looks a little curious, and it's the cast. And this is because C is C and is not very good friends with just putting in a function pointer with any signature into a generic function pointer. And in those OSSL dispatch structures, the function pointer in there is one returning void and taking void arguments. So we need to make a cast to make the C compiler happy. That's life. So here I'm compiling that, and I've used the macro commit ID to get the commit ID. This is actually the commit ID of that specific commit in the Git repository where I made all this. Otherwise, you link the provider as usual. And here you can try it. And this says a little more. The build info parameters turns out into being printed as build info. And we get some information about that the provider actually provides this parameter, saying it's a pointer to a UTF-8 encoded string of arbitrary size. We're all happy, I hope. Moving on to the next thing, query functions. The query function is incredibly central. That's the one function that libcrypto calls to get all implementations of for a certain operation. If you look at the query function at the bottom of the right column, you will see that it takes an operation ID, and that is actually exactly the sort of identities, numeric identities, that are being passed and for which libcrypto expect an array of OSSL algorithm back. In this case, we're having a very, very simple one that you can see for yourself. I have this fictitious generic algorithm that I call blarg that I hope that no one will ever implement. But here's how you declare it in an OSSL algorithm array. The first part of the first string in the structure is all the names, colon separated. So you can give any algorithm a whole set of names. They are aliases for each other. And if you see the last one, it says 1.2.3.4.5, which is a non-existing OID, I hope. But it demonstrates that you can also use a straight OID in this sort of canonical text form as one of the identities for an implementation. The next string is the property definitions. I've chosen to just set an author, x.author equal blay. Any provider, as I think was said in the users track, can define any property it wants as long as the property name has a period in it. The third part of that OSSL algorithm element is the pointer to the OSSL dispatch, which you can see just above it, above the OSSL algorithm. And I'm not showing the whole set of functions because that would take up much more than the space for in this slide. And the last part of the OSSL algorithm element is the description string that just for humans to read. And here I'm saying what I just said a moment ago, that this is a fictitious generic algorithm. I'm not telling anyone not to implement it. I'm just hoping it never happens. So, and this query function is declared back to libcrypto the same way as the parameter handling functions we looked at just a moment ago, i.e. there's this little diff. Which associates the identity OSSL func provider query operation with that query function and with that very curious cast, as you will see repeatedly. And building it is just the same as usual. You compile the object file, you make the DSO from it, and you call it. This time with the OpenSSL list where you say minus digest algorithms, because it was a digest algorithm that we declared. And there will be a whole listing of legacy implementations. That's what the ellipsis is for. We're not interested in those. We're interested in what we provide. And it shows us exactly what I expected. The diverse identities. It says that it's from the Hello World provider, and it shows that description string. Moving on, I'm just going to have a quick look at time. Thank you. Okay. Moving on, the last bit. Getting configuration data. And this is data from the OpenSSL config file. That's perfectly possible to do. because all data that's connected to a specific provider is converted into parameters for the provider to pick up. The way I'm showing it here, it happens entirely within the init function. So entirely within the OSSL provider init. Therefore, I'm not showing a full function. I'm just showing the bits that's added to make this happen. Right. So this is the first time we're looking at the in parameter to OSSL provider init, i.e. the OSSL dispatch table array of functions that library passes down to the provider so that are the upcalls. And here we're interested in two upcalls. One is the gettable params, which is something that libcrypto passes to be able to tell the provider, these are the parameters I'm going to provide to you. And then there's the OSSL, the get params, which is the provider can use to actually retrieve parameters. And that's part of this for loop that you see, where it goes through the in OSSL dispatch array to find those two functions. The gettable params wasn't strictly necessary. It's more for display than anything else. It can be used to verify that, you know, the parameters that we expect to be able to get are actually provided. Here we use it only for display, so it will print all the parameters that it gets from the cgettable params, or parameter descriptions. Next up is here we're actually trying to get something. And we're trying to get two parameters. You can see them up in, oh, my cursors are actually showing. So in this area, you see two parameters being specified. These are the parameters that we're trying to retrieve from libcrypto in our provider. One looks for something named OpenSSL version, and the other looks for something named something. The cget params call is the upcall back to libcrypto, and that actually has libcrypto fill in our OSSL param array with the data that we're expecting, or rather the two variables just above the array that the array is pointing to. And then we simply display them if it turns out that they were filled in. And this is a little trick we use, or that can be used. This size t minus 1 here is a trick to indicate that this hasn't been filled in yet. So after a cget params call, those that will have been filled in will also fill in that position the actual size of the data that's being passed back. And that's how we can then do this comparison further on to see, was this filled in? Okay, print it. So we do that for OpenSSL version and for something. This also happens in OSSL provider init, by the way. Finally, we have a configuration file. And this is formatted according to the manual we have for that. And it's a little bit complex, but what's interesting is that for our provider, is within this group hello_provider. And it tells libcrypto that the identity of the provider is hello world, that it should be activated. And then it adds some extra data. And a bit of a cool feature is that you can have subsections by having just one of these assignments pointing at the name that is a group name in itself. This is what it looks like. So we compile it as usual. And this is, it does some wild printout because there's no easy way that I know of, that I've seen, to get this output otherwise. So we use OpenSSL list to load that provider, and it prints out whatever it gets. So it's been printing out that it found that libcrypto should pass a OpenSSL version, a provider name, and module file name. And we found that yes, it does provide an OpenSSL version, which is 314. That's in my installation. If we pass it this config file that I showed a moment ago, then we additionally get the output of the something, which, if I go back 2 steps, was set to the string, this is something. And that's what we get back here, because when that configuration file is used, we do get that assignment, among other things. One last bit is about the provider context. OSSL provider init takes one last parameter, which is an indirect pointer to a provider context. This is null if nothing else is said, and is for the provider to save away whatever data it wants that's connected to that particular provider instance. And to handle that properly, we need to make a provider context structure. Right now, we have a total nonsense. We have a dummy. And we need to provide a tear down function, which has the responsibility to free this structure and whatever it contains. And we add that tear down to the provider-wide functions that are passed back to libcrypto, just like we do with every other function. So this is how libcrypto will know to call this when the provider is being unloaded. And this is the change that is made in OSSL provider init itself. It allocates space for the provider context. Right now, it's just zeroing it out and assigning the provider context argument with it. There's going to be a few slides more, and they all start from this point, i.e. we assume that we are creating a provider context, and now we're going to start populating it with diverse necessary data. First up is error handling. Error handling can be done in many ways, really, and it's totally up to the provider author to figure out the best way for that provider. This is one example that I personally use when I want to do something very quick. And the macro, that's the part where I said that this will be definitely in C99 because it allows to have variadic arguments in macros. Doing it with an older C version is doable, but a bit more convoluted and a bit too much for this slide. This ER macro can be used almost like OpenSSL's arrays data, with the only exception that instead of a library indicator that is the first argument, we pass back the provider context, i.e. the prov CTX that is created. The prov CTX structure itself, you can see it up top. It stores the handle back to libcrypto, the libcrypto handle for this provider instance, plus 3 function pointers, which are the base functions to create an error record in OpenSSL style. It's a bit convoluted, but that's because we have a certain flexibility and certain way of doing this, with certain things being optional. The set error debug functions, for example, is optional. You don't have to use that at all if you don't want to. I have chosen to use it here as a demonstration how it's to be done. Next up, we need somewhere. Sorry, I'm getting ahead of myself. The provider can also provide reason strings so that you don't get an error where it says reason parentheses number and parentheses in the middle, but actually has some sort of readable string to say, what was this error about? And here that is done with the help of a function that I call getReasons here, which basically passes back an array of OSSL item. And this is currently the only place where you see OSSL item, and it's done to associate a number, an identity that's entirely chosen by the provider, with a string. So this number will be the error reason code that's being used with the ER macro. And as usual, this function is passed back to libcrypto through this provider one functions array, alongside the teardown that we still have to clear out the provider context structure. And just to have an example, this is a complete nonsense example, but it's an example on how to use this macro. And I'm basically making this query function error out. It doesn't return anything useful for libcrypto, but it will generate an error. And this is the example of how to use it. With the unsupported macro that was in the previous slide, and some extra data if you want to. The same way that you can do with arrays data in OpenSSL itself. And of course, we had that query function as a query operation in the provider wide functions. By the way, a small note is that error raised this way in OSSL provider init itself are not rendered very well. There is an issue raised for that just recently. I figured that out as part of writing these slides. And we build the provider the same way as usual. And then we try to use it. Here I'm trying to use it for encryption. And I'm trying to use an algorithm for Blarg. It doesn't provide it, but it comes with an error message, with error record, saying exactly that string that we provided with getReasons, i.e., hello world, this is unsupported. And the additional data that we pass, the operation ID and extra data, comes at the end. The last thing will be about library context. And this is when to be used when a provider actually wants to use OpenSSL functionality in a bit more advanced way, such as when it wants to load provider of its own and use their functionality to build on top of. And there are two ways this can be done. One is when the provider should be a self-contained entity, i.e. whatever it provides back to libcrypto, it handles entirely on its own, possibly through the help of providers under the hood, so to say, other providers. And because OpenSSL requires more and more a library context, we need to make a library context, and here is the provider context that includes a library context plus the tear down function. And then this is what we do in OSSL provider init itself. We create that library context with OSSL lib context new from dispatch, passing it the libcrypto handle and the in, so that any subsequent providers and other things, I think, can take part in the upcalls that have been passed down from libcrypto. This is for the self-contained model. There's also a inheriting model, which is a little bit different in so far that it inherits providers that are called by the libcrypto or whatever uses libcrypto one level above it. And it's the implementation that this provider provides can also be used by other providers that are loaded by the same libcrypto just above it. And the only difference between this, where we did an OSSL lib context new from dispatch, and the inheriting module, is that we call OSSL lib CTX new child instead. And that's about it. And I have a few references. All the code that I've displayed here has been is part of an actual module. It has been tested. All the commands that you've seen are commands that I've made to prove my point. And it's all available in the repository that you see here. I've called it OSSL Webinar Pro Authors Skeleton under my own name so far. There's also a collection of links to diverse other external providers that I have found on GitHub in an organization I call Provider Corner on GitHub. And that's about it.